Good afternoon. Today we will see the problems on laminar flow through circular pipe. Problem number 1. What problem states? A crude oil of viscosity 0.97 poise and relative density 0.9 is flowing through a horizontal circular pipe of diameter 100 mm and of length 10 meter. Calculate the difference of pressure at the two ends of a pipe if 100 kg of oil is collected in a tank in 30 seconds. First we will see what are the given things. Mu, that is the viscosity given in the terms of poise. Poise is the unit. We have to convert this into Newton second per meter square. 0.97 divided by 10 is 0.097 Newton second per meter square is the value of mu. The relative density is given, which is equal to 0.9. We know that relative density is nothing but density of fluid divided by density of standard fluid. Considering this equation, density of oil can be calculated. Density is equal to 0.9 multiplied by 1000, that is 900 kg per meter cube. Diameter of pipe is given 100 mm, which is nothing but 0.1 meter. Length of pipe is given 10 meter. Mass of oil collected is 100 kg in 30 seconds. It is nothing but mass flow rate. 100 kg per 30 seconds is the mass flow rate. We want to find out the value of P1 minus P2, that is pressure difference. P1 minus P2 is equal to 32 mu U bar L by D square. Here mu is nothing but dynamic viscosity, which we have already given. Length of pipe is 10 meter, diameter is 0.1 meter. Only unknown is here U bar, that is average velocity. Average velocity or mean velocity is nothing but average discharge or total discharge divided by area. We want to find out Q. The discharge Q is in meter cube per second. With the given information, mass flow rate is equal to 100 kg per 30 seconds. Another formula for mass flow rate is rho into Q. Rho is nothing but density, that is kg per meter cube. Q is the discharge, meter cube per second. These both equations are giving us the mass flow rate. So we can equate these two, that is 100 divided by 30 is nothing but rho multiplied by Q. Rho is known, density is known, 900 multiplied by Q is equal to 100 divided by 30. By simplifying this equation, we will get Q is equal to 100 divided by 30 multiplied by 1 divided by 900, which is nothing but 0.0037 meter cube per second. Now, average velocity can be found. Q divided by A, which is equal to this Q divided by pi by 4 d square. Diameter is 0.1. So putting all the values and calculating the value of U bar, that is U bar is equal to 0.471 meter per second. This is the average velocity and our first answer. Then we have to check whether flow is laminar or not. Rho Vd by mu, 900 multiplied by 0.47, that is mean velocity or average velocity, multiplied by 0.1 divided by mu, that mu which is given already, and Reynolds number is coming 436.991, which is less than 2000, and laminar flow is present, so that we can use next steps. So P1 minus P2 we want to find out. 32 mu U bar L by D square. We know value of mu, we know the value of U bar, we know the length, diameter is also known. So putting all the values and calculating P1 minus P2 is equal to 1462.28 Newton per meter square. This is the answer which is asked in the problem. With this we are finishing this problem number 1. Let's move for the next problem. I will read the problem. A laminar flow is taking place in a pipe of diameter 200 mm. Maximum velocity is 1.5 meter per second. Find the mean velocity and the radius at which this occurs. Also calculate the velocity at 4 cm from the wall of the pipe. What are the given things? Diameter of pipe. Here diameter of pipe is given 200 mm, which is nothing but 0.2 meter. Umax, that is maximum velocity, 1.5 meter per second. We want to find out average velocity, radius at average velocity, and velocity at 4 centimeter from the wall. Let's see one by one. We know the relationship between Umax and U bar. The ratio of Umax and U bar is coming 2. Umax is 1.5. We want to find out U bar. U bar is equal to 1.5 divided by 2.0, nothing but 0.75 meter per second is our first answer. Now we are going to calculate the radius at which U bar, that is nothing but 0.75 meter per second occurs. We have the general formula U is equal to minus 1 by 4 mu dou p by dou x into bracket r square minus r. I am taking just this r square common. So inside the bracket there will be 1 minus r small r square divided by capital R square. Let's observe over this term, that is minus 1 by 4 mu dou p by dou x into capital R square. This term is representing the U max. So replacing that term with U max, you will get U is equal to U max into bracket 1 minus r by r brackets. Now the radius r at which U is equal to U bar is equal to 0.75 meter per second we want to find out. That is nothing but this r. U is nothing but 0.75. U max is 1.5 in the bracket 1 minus r. This r we want to find out, and capital R is nothing but d by 2, which is nothing but 0.2 divided by 2 is 0.1. So 0.75 is equal to 1.5 into bracket 1 minus small r divided by 0.1 whole bracket square. In this equation you will observe only small r is the unknown. So let's make the simplification, taking all the things on one side, r by 0.1 bracket square on one side, which is equal to 1 by 2, taking the square roots of both the side, that is under root 0.5, multiplying with 0.1 multiplied by under root 0.5, r is equal to 0.0707 meter, which is nothing but 70.7 mm. At this r, we are getting velocity is equal to 0.75. That is the significance of this r. Lastly, we are calculating the velocity at 4 cm from the wall. This is important to learn now. This is the front view of the pipe and this is the side view of the pipe. This is representing the radius of a pipe from the center 10 cm. We want to find out velocity at a distance of 4 cm from the wall. Means on this line what will be the velocity? Means at this point what will be the velocity from the center? So this capital R minus 4 cm will be the new radius. At this radius we want to find out the value of small u. So new radius is r small r, which is equal to capital R minus 4 cm, which is nothing but 10 minus 4, 6 cm, nothing but 0.06 meter. Most of the time mistake happens in the exam by taking directly 4 cm as a value of r. So be careful about that. The velocity at radius 0.06 we have to find out. U is equal to U max into bracket 1 minus small bar by capital R square. Putting all the values and solving the equation, we will get U is equal to 0.96 meter per second. This is the velocity we are getting in at the radius 0.06 meter. Hope you have understood this. Let's move for the next problem. Last problem. An oil of viscosity 0.1 Newton second per meter square and relative density 0.9 is flowing through a circular pipe of diameter 50 mm and of length 300 meter. The rate of flow of fluid through the pipe is 3.5 liters per second. Find the pressure drop in the length of 300 meter and also the shear stress at the pipe wall. So let's see one by one what are the given things and what we have to find out. So given is mu, that is dynamic viscosity, 0.1 Newton second per meter square. Relative density is 0.9, nothing but rho divided by rho of standard fluid. So as per the similar problem which we have seen previously, rho is equal to 0.9 multiplied by 1000, that is 900 kg per meter cube. So diameter is 50 mm, that is 0.05 meter. Length is 300 meter. Q is equal to 3.5 liter per second, which we have to convert into meter cube per second by dividing with 1000. We want to find out P1 minus P2 and shear stress at the wall, that is tau 0, that is maximum shear stress. Pressure drop is nothing but P1 minus P2, 32 mu u bar L by d square. U bar is equal to Q by A, as we have seen in previous problem. Q here directly given, divided by area of cross section pi by 4 d square. So we got U bar 1.782 meter per second. Again we will check whether flow is laminar or not by putting all the values in the Reynolds equation, and we get the Reynolds number as 801.9, and we can say that flow is laminar. So P1 minus P2 is equal to 32 multiplied by 0.1 multiplied by 1.782, that is U bar, multiplied by 300, that is the length, and divided by diameter square, that is 0.05 square. We will get the pressure difference 6,84,288 Newton per meter square. That will be our first answer. Then we have to find out shear stress at the wall. We know the shear stress distribution equation, tau is equal to minus dou p by dou x r by 2. We want to find out tau when r is equal to r, that is tau 0, means at the wall. So replacing small r by capital R, tau 0 is equal to minus dou p by dou x r by 2. Here dou p by dou x we want to find out. Minus dou p by dou x is equal to minus into bracket p2 minus p1 divided by x2 minus x1. Removing the effect of minus sign, p1 minus p2 divided by x2 minus x1. p1 minus p2 is the pressure difference, x2 minus x1 is the length. So length is 300, p1 minus p2 we have found already 684288. So dividing this we will get the value of minus dou p by dou x, that is 2280.96 Newton per meter cube. And radius is d by 2, 0.025 meter. So that tau is equal to 2280.96 multiplied by 0.025 by 2. Nothing but tau 0 is equal to 28.512 Newton per meter square, and this will be a final answer, that is the maximum shear stress. With this example we are completing third problem. Here is the last problem as a homework which you have to solve, and I will put this problem as a LBD where you have to give its answer. Thank you.